So this device right here represents our car. And in each of the four corners, you can see a servo and a respective wing, which represent each quadrant in our fully active Aero package on this car. In the middle here, there is a knob, a potentiometer, which is our way of abstractifying numerous car variables, such as wheel speed, steering angle, etc. But our main data acquisition is through the IMU in the center here, which is collecting X and Y acceleration. So let's open this up and see on the inside. So the first thing that happens when this device is turned on is it connects to Wi-Fi via a Wi-Fi hotspot, like on a mobile device. And then after that, it uses this Wi-Fi connection and then connects to the MQTT client for later data acquisition. After that, it calibrates bias error found in the IMU, and we'll talk about how we do that later on. But then after it does this initial setup, it then constructs a GG lookup table, which can be described as like a basic set of instructions to send the servos based off of the IMU data, and then then the abstractified car data to then instructions for the servos. So on the MQTT side, acceleration and desired servo angles, as well as time, of course, are sent and recorded and then plotted from a host script on a laptop. This allows team members to optically compare the angle of attack of these individual wing quadrants with the time-stamped plots displaying the acceleration at that given moment, as well as the same angle of attack.
Okay, this is the code for our final project. What you see here is the first part of our code, which is the MQTT connection. We make sure that all of it is properly connects to the Wi-Fi, and it will stay connected once it's done. Here is the definition, or our methods for constructing the lookup tables. This one constructs a simple DRS lookup, while this one has more complex values for each acceleration pair. So for every possible reading of the IMU in two directions, we have written some degree values for each servo to move to, and every time that the IMU is going to read values, it's going to pull from this lookup table in order to move the servos. Okay, and then setting up the rest of the IMU board, we have setting up the IMU, the ADC for the potentiometer, as well as 4 different pins we're using as output for the servos. We have set a variable for resolution in order, if we want to change the resolution of our tables. And after instantiating some of the variables, we can get to our first step, which is calibrating the IMU. So we print out some output and turn on the LED. We can sample the noise from the IMU for 100 values or more, depending on how many, and then find a mean value of that to use as cal-x, which is our calibration value that we'll be offsetting all of our raw values by during this data collection loop. So in this data collection loop, we'll be collecting the raw x, raw y, raw pop value, and throwing them through an exponential smoothing method. So this section just smooths out the values so that they don't change or are not so responsive and not so jagged. And then we sort them into bins according to our resolution, so that it'll match some key on our lookup table. Here we gather this the value that our IMU data would pull from our lookup table, convert it into duty using these formulas. And for each motor, it's a little bit different, especially since we applied some bias between the front and the back servo motors, depending on the potentiometer reading. So after that, it's just converted into duty, which turns the servos to their appropriate location. And then that is recorded into MQTT. So the degree values are all sent over MQTT and graphed in this graph right here, which is a graph of acceleration and servo wing angle of attack with respect to time.
All right, so now that we've covered the hardware and the code, let's look at our experimental setup. So at the front of this cart here, which was a previous project of mine, we have our device mounted. We have a rigid plastic base mounted to the chassis. We have it powered as usual, just via the 2 batteries that are on board. On the back here, there would normally be a phone to record the footage here of the angles of attack changing. And then because we are running at nighttime right now, we do have a little spotlight shining down on the setup so you can see everything.